Sorry. That's Prashan. Rice. Reese. And Zoe. Okay. Right. And Zeno. Okay. So if you want to, actually, if you could all come much closer, you don't have to. If we can sit around on the first table here, mainly because the style of teaching that I do is more conversation. Come closer, come closer. Right. So, welcome to this fourth segment. 602 is consisting out of two sections, which is a design section, which I teach, and an evaluation section, which I now also teach. It used to be another teacher, but I took over that part. So you see me twice a week. I hope you can bear. And today, so Mondays is design, and Wednesdays would be then the evaluation part. Right. To start with, I would actually like to know a little bit about you, mainly so that I know roughly what your backgrounds are and what your pre-knowledge is, because I might or might not speed up certain things. Do you maybe want to give it a start?
Sure. So I'm Zoe. I did my bachelor's degree in design innovation in Victoria University in Wellington.
Mm-hmm.
And then during my career, I've also developed skills in some CSS and HTML, so I transitioned into digital design.
Okay.
I'm Prashant. I'm from India. I have a background of computer science, bachelor's degree in computer science. Like for the past 2 years, I've been working with airline software design.
Mm-hmm.
I'm from Florida. I went to the University of South Florida and majored in history and environmental policy. And I have a background in corporate tech support and legal assisting for real estate and probate.
Wow. Wonderful. And Simon?
Well, I'm Simon. Nice to meet you. And I'm in my bachelor degree in the major of journalism. And then I did my master degree in the major is public relations. And yeah, I'm here as a visiting academic this year. Yeah.
Right, so as you can see, all four of you have got very different backgrounds, and that's a good thing, because you can, to some degree, learn from each other, and you can help each other, and that's usually a very good thing. It also has another side effect, and that is that at least one of you will be bored at all times, because when I talk about design, you'll be like, yeah, oh, I know that. And when it's about computer science, you'll do the same thing. So I usually set up my teaching in a way that it almost asks a little bit too much of you, because the assumption is that in one of those three major areas, which is evaluation, user, and technology, you'll be strong in one of them, and you'll be able to do this quickly, and the other two will be harder for you. So in that sense, you might actually find these assignments quite easy. That's good, do them, and then you have a bit more time to deal with those things that you are less experienced with. So, the other thing, of course, is that, there's always an endless amount of depth, like even though you might already be familiar with design, when you can design a poster, but it's still always a challenge, and you can still challenge yourself to do a particularly good poster, right? So, yeah. So my background is I did a first study in industrial design, and then I did something, I guess, human-computer interaction, and then I taught in the Department of Industrial Design for many years. And I know a little bit about everything, but nothing really. So although I teach kind of design, I'm not the designer, who dedicated his life to design, does nothing else but design, so I'm more of a generalist than a specialist. So I guess that reflects also a little bit in the kind of the goals that I set out for this course, and that is I want you to learn typographic basics, and I want you to be able to apply these to a visual design. And the idea really is that, you know, since this is going to some degree into an artistic direction, you know, there are rules of thumb, but you can of course always break them, right? But unless you know what the rules are, it's pointless breaking them because you really don't know what you're doing. So in that sense, I want you in the first instance, you know, let's get to know the basics. Let's learn how you're supposed to be able to do it. And then later on, you can then decide to, you know, break them, modify them, or just follow the rules. Or rules, guidelines, I suppose. So we always have kind of roughly the same pattern, which is we would start off with just discussing, you get an assignment every week, and we would start off that we talk about your work, and then we have a conversation, and then I'll confront you with a new task. Since you haven't done a task yet, the first part obviously can't be done yet, but the second and third part will come along. The conversation is really more of a conversation. So far, it's only been me talking, but that will change quickly because, yeah, I'm a big fan of conversation. All the assignments should be submitted through Learn, and I think you've already been introduced to Learn. Not yet? Okay, we have an electronic learning environment called Learn, which is based on Moodle. And that is how we handle essentially all the course material and also the submission of assignments. So it's just learn.canterbury.ac.nz, and most of my assignments, and also all of the other teachers as well, essentially ask you to upload your results to Learn. And all the assignments, all the links, all the videos are essentially put there. Okay, one thing to make my life a bit easier, if you submit something, please submit it in the form last name _ task number. So, because very often if you call it like final design 0.3, you know, .pdf, I never know who did it, so it's a bit more difficult. So if you can please name your files appropriately, that makes my life a bit easier. Right. Any questions so far for the organizational issues? You don't have to do that, the slides are also up there. You can let it, yeah.
Still have the e-learning, it cannot beat.
I think we can arrange for that, yes. So the lecture slides themselves are up there as PDFs, so you don't have to take photos or anything like this. Should be okay, in theory. Other questions? Rob, have you already talked to them about the pattern, about the weeks, what's going to happen with what week? Okay.
Not yet.
Okay. So we have prepared a schedule for you in terms of there will be weeks of lectures, weeks of project work, weeks of thesis work, and I think we also have 1 week off. And they will be essentially in Learn. So you just need to look up the schedule in there. But we start off, which I remember from the top of my head, with 4 weeks of lectures. The assumption is that you are here full-time and that you work on this full-time. If you have other arrangements, then that is your decision, but the assumption is that this is a full-time program, so we would expect you to be here 9 to 5. And it also really helps the group spirit, you know, if everybody's here all the time, you've got a desk here, and we hope that you form some sort of little community. That's kind of the idea of the program. Some of the work will be teamwork, and of course when you've got 3 students, then you'll be the team. Yeah, and particularly with the project work, that will be teamwork. Other questions so far? Okay, right, then let's start the conversation. Usually, when you have an object on a screen, there are two ways that a computer handles these kind of objects. Can you think about what these objects are and how they're being handled?
Text and image.
What's the difference?
The encoding.
What do you mean with encoding?
Like text can just be plain text, but an image has to have a file format. So it's encoded.
Does text file also have a file format?
Usually it has both, yeah.
So what's the difference?
The size of the file, certainly. What's
Okay.
in it?
So what is in it?
Text is text, and images are pixels.
What is a pixel?
It's the smallest unit of an image.
So the difference between, so we've got images which consists of pixels and text, characters. What would be a circle?
It depends on whether it's what file, like what format it is. Like if it's a 0 or an O, then it's text. And if it's a like circle.gif, then it's an image.
Okay, so you can have a circle as an image, and you said you can also have a circle as text.
Well, I mean, it looks like a circle.
Okay, but how would that be stored? How would you draw a circle?
Sorry. So we're talking about what is displayed on the screen currently, like just trying to figure out.
If you were to draw a circle
Yeah.
on a computer screen, what would you do?
Well, again, doesn't it depend on which program you're using? And,
So what would you do?
well, in a design context, with like in design, I would draw a circle using those tools.
You would use InDesign.
Yes, or Illustrator. I would use. I personally prefer using vector tools as opposed to Bitmap and Vector.
So you said vector
Yeah.
and bitmap. You said image and text. How are these two related?
Is that process differently?
Yes, they're processed differently. That's what we're after.
There's one a path, like defined by a path, and one is an exact coordinate.
What do you mean with exact coordinates?
Like a pixel in a bitmap is a very precise location, whereas like vectors are processed according to a path.
One is done based on mathematical calculations, the other is just simply reading and displaying.
We're getting pretty close. So what we need to have is you can represent a circle as a mathematical formula. And see, the interesting part is a computer scientist says a mathematical formula. You've never seen the math behind it. You only see the circle in Illustrator.
I have seen a little bit of the math, but like from a just a CSS and HTML perspective. So.
Okay. But have you ever actually opened a PDF file in a text processor?
No, I haven't seen like the bitmap kind of data either.
Yeah. So it's very interesting. We've got very different perspectives here. Actually, it's actually fabulous because we've got a technical side to it. You know, like it's math versus essentially an array of numbers which represent pixels. We've got a design perspective here. It's like, okay, I use Illustrator for this, and I use that, and almost like I don't know.
Stupid attorney, one-way attorney.
No, but that's an interesting thing because you split it up into images and text, right? Which is a very different. It comes from a content point of view, right? So you look at it from the content lens, right? Which is a completely different lens again. Oh, very interesting. Yeah, so you can indeed represent a circle in both ways. So what are the advantages and disadvantages of these?
The vector is more scalable. and that it'll look more high resolution as opposed to a bitmap generally.
So when you mean scalable, you'll have to explain that. What does it mean scalable?
So you could increase the size and you'd still have the same, like the display would still seem as crisp, I guess, if you maintain that crispness of an image.
And what happens if you make a bitmap bigger?
It becomes more distorted, the vision.
Distorted? What do you mean by distorted?
Well, it looks like more fuzzy and is a lower, like basically looks lower fidelity at a higher scale.
Can you explain why?
Yeah, because it has a limited number of information. So it might be just for a particular screen. If you do the same thing in a different screen, it won't have enough information to display that big in a different screen. It has just a limited number of data, like a small circle. In the other screen, you will have to display it in a larger surface, so you might not have enough information to display it on a larger screen. And this will depend on the computer as well, because the vectoring might take more processing power, the other one just shows up, so it might not need that much enough power to display that.
So essentially, that's pretty much correct. So the problem with a bitmap is that you have a certain amount of information in it. And yes, I mean, you can easily ask Photoshop to make it bigger, but a computer cannot invent new information and give it more detail. Essentially, the only thing that happens is that, you know, the pixels get bigger, but that's pretty much it. So you don't gain any quality whatsoever if you make a bitmap bigger. So what are bitmaps then good for?
Small file size.
Really?
Well, I need smaller than a vector.
Applications that are not scalable.
Do you agree?
Somewhat, yes. It's more suitable for applications that are not scalable.
What are applications that are not scalable?
Say, for example, a game, if you're playing it just on a particular screen size, then that would do. Because we are not upscaling it.
From your experience, what is usually smaller file size? Vectors or bitmaps?
It really depends on, like, with a bitmap image, what device you're using to take it and how you're saving it and a lot of other things as well. So I think it depends.
It depends. Undecided? or is it don't know?
Just think size-wise vectors would be small, because it's just the formula.
That's correct. So if you have, you know, those few lines of code versus, you know, an array of numbers, those few lines of code win. So file size-wise, vector will always win. Scalability, yes, of course, you know, vector wins. So why do we still have bitmap?
Just want to process it as sometimes if it's a low power device.
It's not processing power, nothing to do with that. But there's one form of bitmap that you use all the time that you just can't do in vectors.
Icons?
Hmm?
Icons?
No, even more mundane. I think you probably used it today already.
Photos.
Yes. Photos. All form of photography records its data in bitmap, not in vectors. And that's what bitmaps are good for, photography. Pretty much, well, unless you become very artistic, not much else. Because as soon as you can use vectors, you do use vectors. But photography, you can't. Now, you brought up this interesting issue that, you know, let's say a circle can be stored as a bitmap, but it can also be stored as a vector. So you can transform one to the other. That's actually possible. So let's say we want to move from vector to bitmap. What do we do?
I can show you how to do it in Photoshop.
That's good. I can show you that too. But what is the idea behind it? What is Photoshop doing?
Sets the math in the state that it's in. So, like the formula is calculated to be at a certain place, and then you just freeze it like in that place, in that state.
What is the formula?
Like the current size of it.
You draw a circle using the formula.
Say again?
Then you draw a circle using the formula.
Mm-hmm.
Then take a screenshot of that, like that.
Mm.
So the vector becomes that.
Yes, that would be, like screenshot, whatever. Yes, that's possible. Yeah, but what is the process of internally doing a screenshot?
It's actually, after drawing, it's like taking the values how it would have been if it were happened.
Right, but this would introduce a dependency, because that means you can only put into a bitmap format the size of your screen. You couldn't do it bigger than that, right? So it would limit yourself, which might not be so nice. So how do you get from the left to the right?
You draw a circle and then write down the values of each pixel.
Where is the pixel on the left? Take a pen. Show me on the whiteboard. If we have a marker.
See, this is our. We are drawing a circle.
Mm-hmm.
Okay, using vector.
Yes.
After that, we will be taking the values of each pixels.
Yes.
And
So
we
each
have
square. Mm-hmm.
like this pixel, this pixel, this pixel, this pixel, this pixel, this pixel, and we'll be drawing. It might look like this one, but when there are large number of pixels, when the grid is so large and the vector is so like this, we might get a sharper image.
Mm-hmm.
So that might be one way to do it.
That's a good way of doing it. That's pretty much how it's done. And please keep this little drawing in mind, because we'll come back to it later. The reverse, of course, is also possible, and you might know the name of that.
The name of what, sorry?
Turning a bitmap into a vector. In Illustrator, what is it called?
Well, I would turn it into an EPS file.
Into what?
Like if I was taking a bitmap into a vector, I would,
No, the other way around. From bitmap to vector, what would you do?
Well, I personally would bring it into Illustrator
And
I
then?
would live trace it.
Yeah,
Which would,
yes, it's called tracing.
Yeah.
And unfortunately, that math goes a little bit beyond the course. And but it's good that you know that it exists. And Illustrator, for example, has functionality built in, and you can play with this a bit. It has all sorts of parameters that you can tweak, but you can essentially turn a bitmap into a vector as well. Right. Now, that's all good so far. Now we're coming back to a very, very mystical question. You brought up actually, Rice. You said a pixel is the smallest unit of information. What is the size of a pixel?
Depends on the display.
Why? How?
Because if it's like a phone screen, but it's got a high resolution, if it's like a 720 phone screen versus 720 on a monitor that's this big, the number of pixels is the same, but the area they gotta cover is different.
Okay, so the word, what you refer a pixel to is something on the screen. Yes?
Mm-hmm.
Okay, what on the screen are you referring to?
Like a certain point.
A point on the screen?
Yeah.
Okay, do you know how an LCD display works?
Yeah.
Can you explain?
It's like lots and lots of little dots of light, basically.
Roughly speaking, yes. More precisely, anybody knows more precisely?
It has a polarizing panel in front, and if which one, the LCD one or how the pixels?
Where's the pixel on here? Where is the pixel on there? Come on, let's get close. Let's have show me the pixel.
Well, it's hardly distinguishable to our eye.
Yeah, come on, show me the pixel. Where's the pixel?
You can see the matrix.
So there's a grid, right? Okay, we can see a grid, but what else can we see? When white is not maybe a good question, not a good color to show here, but it's not really white that we see. So how many colors does this thing actually do?
16.
No.
3.
Yes. Which one else?
Red, blue, green.
Yes. Okay, so how does it work? So when you have actually, so on the screen, we see a grid, but each grid consists of a green part, a red part, and a blue part, right? Squeezed tightly together so that your eye perceives it as one. And you call that a pixel. And you say like, well, these units are sometimes bigger and smaller. Is that correct? Okay, right. So, and what you're saying is like, well, this screen, the grid is like this big, the grid, and you see over there, right? And on other screens, the grid has got a different size. So what does it mean? What is the size of the pixel?
It's one of those units on whatever screen.
Correct, so it depends on what you display it on, right? But how much information do you need for each pixel?
30.
Yes. And what are those pieces of information?
So, sorry, the colour values?
Yeah, so, which are?
The RGB.
Yeah.
Yeah, so like 2 by 5 and
Yeah.
0.
So each pixel then consists of at least 3 pieces of information. And the size of the pixel depends on how you display it. Right? So in the information of the pixel, it doesn't say the size. Right? So, which brings us to a related topic, which is really important. The topic of resolution. What is resolution? What is the resolution of that screen?
Maybe full HD.
Which means?
1920
Mm-hmm.
That's the number of pixels. 1920 into the 1820 pixels that we have.
That's the resolution of it. Unfortunately, that's incorrect. That is the number of pixels. That's not the resolution.
Okay.
What is the resolution?
Closely they packed together.
Exactly. Resolution is a measurement of density. So how is resolution measured?
DPI.
Which stands for?
That's correct.
What is a dot?
It's like, well, I think theoretically it's the smallest little drop ink a printer can make.
Interesting. But this is not ink.
Is it points per inch?
What is the point? Now, here's a good one. You all used Microsoft Word, I suppose, at some point in your life. Let's say you type in the word math, and you take the capital M, and you give it a 10-point size. How tall will it be when you print it? Okay, none of you knows the answer, so that's interesting. Think about it. You use it every day, and you have no idea what it means. So point is the question, what does a point mean? What does dot mean in dots per inch? And you mentioned something as well? You said another measurement for resolution.
Pixels per inch.
Pixels per inch. Right. So we got 3 different measurements now, 3 different units now to be precise, that you could talk about when you talk about density. Now, all of this, of course, has something to do with a shift in technology. I mean, as you mentioned before, we started out with ink, and now we've got computer displays. So the problem of resolution is older than computers. That's one thing. But also it kind of illuminates almost a little bit about computer history. Really, it does. So you've done web design?
A little bit.
You seem to have done a little bit of web design? Ever? Okay. So when you ever have, a bitmap graphic, let's say you do a GIF, what resolution do you usually give this GIF? 300. Yeah, but that's not for printing. It's for web design.
Or 72.
Why 72?
I think it's to do with that. It'll be good enough on a printer display.
Maybe. But why 72? Why not 100? Why not 50? Why 72?
Balance between quality and space used.
Did you ever came across the 72?
I would be completely guessing here, but I don't know. I just divisible by 12.
Have you ever come across it?
Come across.
Have you ever seen the 72? Did anybody tell you it's supposed to be 72 dpi or ppi or whatever?
Yes, I was working basically as a designer, not as the web developer. I was told that things should be 72.
Did you ever ask yourself why?
Well, their logic, the web developer's logic was that it would be good enough to display on a variety of devices. That's basically what they said.
Do you think that this screen has got 72 pixels per inch?
It's got more than that.
How about your phone?
More than that.
Do you know any device that has 72 pixels per inch these days? So why do we still cling on to that?
The pages need to load fast, but at the same time need to preserve some quality.
The human eye can't really tell. Maybe that's beyond 72.
No, unfortunately, that's not the case either. Okay, so you were from the US, was that correct?
Yeah.
Wonderful. So you are familiar with the imperial system?
Yes.
And now, anybody?
So is it like that it's divisible by 12 and that's...
No, but do you know what a foot is? Or do you know what...
12 inches.
Or an inch? Yeah, roughly you know an inch. Eh? Okay. Yes, that's true. So as I mentioned, the problem is older. It's older than computers. Because printers were there way before we had computers. Right? So what company was kind of the one that went first out to do desktop publishing properly? Yes. And, does anybody remember this old little chubby Macs, the first one with a graphical user interface on it? Right? Those screens that were on there had 72 dots per inch. Right? Because the idea was that they wanted to match that. Now the question is, match it with what? And that comes back to the question about the point. Right? What is the size of a point? A point is a unit that comes out of the history of printing. Right? You all use it. None of you knows what it means. Right? But it comes down to that you essentially have, in the American system, you have 1 pica is 12 points, so 1 point is 0.35 millimeters, and 1 inch has got 72 points. It's an old unit of measurement from printing, so there are 72 points in 1 inch. Now, if your screen has the resolution of 72 points per inch, then what happens? When you see something on your screen and you print it out later, you are very close.
Each pixel will be an inch.
Every pixel is a point. And that's the beauty of it. So it's not random that Apple chose to give its display 72 dpi. It gave it so that a dot on print is the same as a pixel on the screen. So when we take the word math and we give it a 10 point, it will be 10 pixels high on the screen, and it will be 10 point high when it's being printed. Right? So that's where that's coming from. So, but coming back to the question, math, capital M at the beginning, 10 point, how high would it be? Now you can answer this. Yes, say louder.
3.5 mm?
Yes, 3.5 millimeters. Of course, the bizarre thing is that why do we select for our typography a unit that we don't know what it means? You might as well say, okay, I want to have a Helvetica size 10 millimeters or 3 millimeters. You could do that if you wanted to, but somehow we still, hold on to this idea of a point, although it largely lost its meaning. And it's based also on an old imperial unit system, which really doesn't make any sense. Well, why would you divide an inch into 72 parts?
Why do we have to do our hardware in 3/16?
Yeah, so that's, it's interesting, it's a history lesson, but it also really highlights the relationship between points, pixels, resolutions, and so forth. Now, these days, when you do web design, you never know what resolution the screen will be on, right? So, in that respect, making a design that looks good on multiple devices that have not only a different resolution, but also a different overall size is a challenge. So making things scalable, making it look good on multiple devices is a challenge. And one way out, of course, to do it is to move away by using the unit of pixels, and you can just say, this box should be 1 centimeter tall. And the device itself figures out how many pixels it needs to display that. Right? We're getting there sometime. Now, that's all good and fun. Now, let's talk. We already talked about that we need 3 colors for each pixel, right? We did that one already. So, if you have our standard printer over there, you saw a standard big printer? How many colors does it have? The big laser printer standing on the corner.
3 or 4?
3.
We actually got 2 printers. We've got a black and white printer, and we've got a color printer. So let's start with the one in the corner.
Which one's that?
Literally on the corner. It can't print color.
Oh, okay. It's just gone.
So how many colors does it have? One. Which one? Okay. And the color printer? 3?
Four.
4. Which are?
Signed into K, which is black, and yeah, sorry.
Yeah. So cyan, magenta, yellow, K, called in short SMIC. Good, we know that. That's good. Now, one thing to remember is, of course, that when we talk about print, we talked about 300, you already said, and you talked about 72, which is just about good enough. So the question is always, what is good enough? Right? Because when you print, or if you do a big poster, you don't want to overkill your design. Right? You don't need more detail that nobody can see. Right? So this is the rule of thumb. So even at the best quality for printing, you don't need more than 300. So everything above is just wasted effort. Don't bother. For offset print, we still get another unit in there, which is called lines per inch. And that's a very, very curious measurement that I have not been able to exactly figure out what exactly they mean with that. So that remains still even a mystery to me. They tell me it's the distance of the lines of the grids, but it's difficult for me to fully conceptually understand that. But anyway, so that you just said you heard it, LPI is another measurement, right? Now, Rice, could you be so kind and borrow me that piece of your name tag? Oh, it's letter. Oh no. Okay, let's pretend for a moment this is not letter. Let's pretend this is A4. Okay. What size is this?
In millimeters.
Mm-hmm.
210 by 297 millimeters.
Mm-hmm. 297, yeah. That's correct. Okay. Now, actually I really need an A4, otherwise it doesn't work. I'm sorry, up here it really stinks for this one. Does anybody have an A4? No?
Is there paper there?
Oh, we got one, yeah. Oh yeah, it's all splendid, yes.
Do not touch. Oh, well, I think it's a little bit.
It's been touched, so it's not good. Okay, here we got an A4. Right? Beautiful. So we know the size, right? What's the proportion?
So, other than A4?
Proportion. Do you know what proportion is? The relationship of this length to this length. Any idea?
3 to 4.
Okay, but it's wonderful, right? If you could be so kind, take your piece of paper and fold it in half. Is that the same proportion?
Yeah, as it was before.
For you?
So, maybe it's, no, it's narrower now.
Ah, and this?
That one is the same, isn't it?
It's the same.
We don't have fancy paper like that. Come on. We got it. I'll fire one.
You see the magic of this? So what size is this?
A5.
Okay. What size is this? Is it still the same proportion? It is. So, there's a certain magic to specifically this proportion. Can you imagine what this is?
millimeter?
No, 1 to 2 wouldn't work. Say it again?
2:4.
No. So since you simply don't know, it's 1 to the square root of 2. That is the proportion. And this proportion allows you to fold and always maintain the same proportion. And that's the beauty. Well, actually, it's not A4, to be extremely precise. It's called DIN A4. Anybody knows what DIN stands for? Have you ever heard it? Really? Never?
No.
What an insult.
I've heard it, but I don't know the context.
Okay. It refers to Deutsche Industrienorm, German industrial norm. It's the freaking Germans who came up with this.
That's why it works.
Exactly. So now we know the proportion, which is nice, but we still don't know. The proportion is independent of the size, right? So an A4 could also be just a little bit bigger, as long as it's in the same proportion. Why did they select this absolute number of 210 by 297 for A4?
I have no idea.
Gonna guess because you can fit a certain number of lines of text of a certain acceptable size onto it.
No, it's actually much more mundane.
Easy to hold.
Easy to hold. Okay, remember, this is printing. This is way, way, way before computers, right? So let's say I'm a manufacturer, I'm a printer, and I'm going to order 10,000 pieces of A4, and then it's being delivered. How do I know that I've been delivered the right number of papers?
By the weight?
Yeah, so you wouldn't count it, would you?
No.
So you would weigh it, right? So what's the weight of this?
80 to 100 Gs.
Okay, so let's just for the sake of argument, let's say it's 100. It's a little bit heavier than normal, but say it's 100 grams per square meter, right? So how would I know that you've given me the right number?
Does it fit into a square meter real nice?
Sorry?
It fits into a square meter really nice.
Yes, it does. So what fits into a square meter?
The size of that sheet of paper.
Sort of, yes. So what is A0?
The whole square meter.
Exactly. A0 is exactly 1 square meter. And so if you get being delivered, or if you get a delivery of paper, and you know the weight of the paper, you now can calculate exactly how many sheets of paper you got by weighing it. That's the whole point. And that's why it is exactly 210 by 297. So that A0 is exactly 1 square meter. I almost feel like a history teacher.
No, that's good. I had no idea that was why that was it.
Now, in the US, what kind of sizes do we have in the US?
8.5 by 11 and legal.
And one more.
Tabloid, I've never heard of.
No?
No. We don't really use legal paper anymore, even in the offices, though.
Yeah.
Not since the 90s.
So the only thing to remember is that letter, and you see it right here, is, A4 is a bit taller. So if you make any kind of design that you want to distribute internationally, you have to make sure you don't put anything up there, because when the Americans print it, they might not see it.
Is it narrower too?
A4 is narrower, you see there. I put them there.
Oh, there we go.
Yeah, I've had issues in the past where someone's preferences in design have been set to leisure, so it's always interesting.
Well, it comes a bit again to kind of like a bit of the design of that fits everything on everybody. Huh? When we talk about screens, of course, things get more complicated. I mean, history. I mean, in printing, there are some standards now, like the Deutsche Industrienorm DIN, which kind of specifies. One more question. We've got DIN A4, but we also have DIN B4. What does the B and the C stand for? Let's say, what is DIN B6? What is it used for?
This is just complete guess. Are they like envelope sizes?
Yes. See? It's all a system. A fits into B, B fits into C.
Clever.
Do the whole rest of the world do it that?
This is a whole new thing. I'm sorry.
It's envelopes. So when you buy envelopes, you buy them in DIN B6, B5, B4. And if you want to put an envelope into an envelope, you use the C series. Now, screens. So, I mean, for printing, we've got some standards. For screens, oh boy. Let's say it's complicated. Right? We've got kind of 4 major proportions. But other than that, there's, it's pretty wild in terms of sizes, resolutions, and it's a true challenge for a designer to create something that really, fits on or looks good on different screens. It's quite a challenge. Even finding names for it. I mean, you've got these acronyms, which HD, HD plus, UXGA. I don't know whoever comes up with this, but it's not as simple as A4, A5, A6. It's really wild. Google used to have a tool called Browser Size, and what it does is that they actually record the screen sizes that people have when they come to the Google website, and you could just type in any kind of URL, and it would show you the proportion of people who are able to see in your page, so 99% of the people will be able to see this, 9% of the people will be able to see this on your website and so forth. And this is being updated, and so you get a good idea about, what people can see of your web page. We, of course, are spoiled with our large screens, and we have to be careful. I mean, that's the typical problem. It looks good on your screen, and you think, oh, I'm done.
But if the end user has to side scroll, they'll hate you forever.
Yes.
Oh, they're not responsive at all.
Yeah. There's also a nice little calculator here that you can use to look out exactly what your resolution is for your screen. So you type in, the number of pixels and diagonal size, and it calculates the actual resolution of your screen. That's screens for you. Now, we talked about weight. So how much is this?
100 Gs.
Oh, we agreed on it, but usually it's like 90, or if you're cheap, 86 or something like this, right? So there are some other weights. So you have semi-cardboard, cardboard, and even pasteboard. And these are just names of the thickness of the material. And of course, the heavier it gets, the stiffer it gets, and it depends on what you want to use it for. Usually, inkjet printers are a little bit more forgiving in terms of heavy paper. Our papers are really made for for this, so don't stick anything too thick to it. It might actually not like it. But you can look up the exact specifications because they will specify exactly what's the heaviest paper that you can put through it. Now, file formats. We talked about this before. You talked about this before in terms of the file is smaller or bigger, right? And one of the things that is being done, of course, is that we don't want to clog up people's hard disks too much. So we try to keep it small, and we use something called compression to make it smaller, right? So if you take an image and you save it as a JPEG, what happens?
Some of the data gets discarded.
Yes. Is that good or bad?
It's good from a perspective of not taking up too much space, but bad from the perspective of then you can't scale it up without it looking fuzzy.
Okay. So when you start, if I open and save it, let's say 10 times, and I open it and save it as JPEG, open it, save it as JPEG, open it, save it as JPEG, what will happen after 10 times? Nothing. Optimist.
It might shut off some pixels, a very few, because while saving, if it's a lossless saving,
You said lossy, lossless. What now? Lossy or lossless?
lossless.
Well, is JPEG lossless?
It can be saved either way. Lossy or lossless.
Yes, there's JPEG 2000 and some other newer formats of JPEG that is lossless. But most of the time it's lossy. So if you apply a lossy algorithm to it and you lose a bit of quality every time, so after doing it 10 times, what would it look like?
Almost the same, but some pixels would be.
You're such an optimist.
Yeah, it would look like that.
It would look quite horrible. Yes. So, what does it mean for you working?
Don't save it in the JPEG until the very end.
Exactly. Don't compress it.
Otherwise, we would duplicate it in the file. Yes.
Yeah. So don't compress it with a lossy algorithm until the very end. You can use lossless ones, like for example PNG is lossless, and then you do not lose any quality, right? Another misconception is that, my computer has not so much RAM, so I'd rather save it as a PNG so my computer can work better with it. Unfortunately, the compression only works for saving on hard disk. It does not help at all for your memory of your computer. The image will take the same amount of memory, so it doesn't help. It only helps for saving space on the hard disk. So, don't touch anything lossy until the very end, until you deploy it, so to speak. Now, so what is PDF?
Portable document file. English.
Yes, that's the acronym, what it stands for. Why do we have it?
So everything will look the same no matter what machine you open it on.
And how is that achieved?
Magic.
So that's your department. You're the official magician here, you know? It's called auto-magically. So let's take another scenario. Let's say you create a Word file and you put a bit of effort into making it fancy and use some weird and freaky fonts you downloaded from the internet, and you send your Word document to you and he opens it. What happens?
Or the fonts aren't installed and not installed properly.
Why is that?
because the computer doesn't know what to do with them, it'll just make the best guess it can, and it'll end up with like Times New Roman or something.
After it defaults.
Okay. So the problem is that when you send a Word document, it doesn't include the fonts, for example. So how did PDF solve this problem?
Makes it an image-based as opposed to...
No?
Looks more available intuition.
No?
Some kind of intermediate conversion is happening, right?
No, it remains editable.
It includes the font information in the file.
Yes. You just package the font with the file.
Although it doesn't for accessible PDFs often. If you the interactive ones.
Well, you can, when you, PDF has become a bit of a monster. And there are many, many different ways, so many different flavors of PDF these days. PDFX, PDFA, you know, there's all sorts. So it got a bit more complicated. But in principle, the idea is embed the fonts. Now, PDF is actually, let's say, an evolution of something older called PostScript. Right? First, there was PostScript, then there was PDF. They had the same idea. But what happened, of course, is that the internet happened. Right? So the problem, again, is older. You know, the problem with computers is older than the internet, because there were computers before the internet, obviously. But anyway, Adobe at some point realized, oh, the internet is happening, interactivity is happening, so essentially they beefed up PostScript to have some more interactive features, and that then essentially became PDF. So before that, we also had encapsulated PostScript. But if you want to be super safe, this is something that, you know, sometimes I do when I give something to a printer, and I have my Illustrator file. Actually, I don't just save it as a PostScript. I do one step before. I convert all the typography into
Outlines.
yes. And what are outlines and how are they saved?
Is an EPS, or quite often.
What happens if you convert, let's say, a headline to an outline?
It groups all of the individual elements into one object.
Mm-hmm.
And flashes it into one picture.
Can you, let's say, if you converted it to an outline and you spot a typo and you want to correct the typo, can you still do that?
No.
So what happened?
It becomes, I don't know, half rather than individual elements. That's all I can really phrase it as.
That's pretty correct. So instead of storing what you said before, the content, the letter A, right, and it would not store letter A at this spot with this font, it will actually convert it to a path. And the path is a mathematical formula. It would actually mathematically describe the A and discard any relevant reference to the original font. The beauty of that is that it can't really break anymore because you really broke it down, and you know, if the printer does or does not have any fonts installed, it doesn't really matter anymore, so it makes it safer, but also disables you from editing it later on at all. Now, what software do you use? Let's say you want to do some photo editing. What software do you use?
Photoshop.
Or Lightroom.
Photoshop.
Photoshop, Lightroom. What's the difference between Photoshop and Lightroom?
Depends on what you want to do with the photo. I mean, if you just want to touch up like 20 photos of a mountain, then Lightroom. But if you want to make me look skinny, then you need Photoshop.
Nice. Yeah. So, unfortunately, by now we have a monopoly, pretty much. Adobe is running the show. There are some alternatives. So there is the free alternative to Photoshop is called GIMP. So you could use that if you wanted to. If you wanted to do a poster, what would you do? Ah, you disagree. Why?
I find InDesign user face supports grids more than Illustrator does, really, as well as the ability for multi-page documents if you're doing more than a poster, but also the typesetting tools I think are more advanced in InDesign than they are in Illustrator.
Mm-hmm. So you defend InDesign now? What's the advantage? Why would you use InDesign for a poster?
I would just Photoshop, but InDesign is the best tool I have heard. I would be using Photoshop if I want to design a poster, but still.
Okay, so why would it be a bad idea to use Photoshop for a poster?
It takes more time because InDesign would have the tools which you might mostly use by design. Photoshop has everything, but it's arranged differently.
InDesign also supports the print industry, I think, more than Photoshop does. So there are more presets that support a faster process in InDesign, hopefully.
Well, the lines are getting a bit blurred, these days, because it used to be that Photoshop only does bitmap. It didn't know vectors. By now, Photoshop also knows vectors. And by now, you can do bitmap stuff in Illustrator, which you couldn't before. So it's been a bit blurred, but fundamentally, Photoshop is bitmap based. Can you imagine how big an A0 bitmap is?
But if I was doing a more illustrative-based poster, I'd use both InDesign and Illustrator.
So the rule of thumb is that Illustrator stereotypically is meant for a one-page thing. It can by now do more than one page, yes, but it's meant for one-page design, and it has very elaborate tools for artistic expression, whereas InDesign is made more for multiple pages, books, booklets, these kind of things. That's where actually the emphasis is. Of course, ultimately, you can do your poster in PowerPoint if you wanted to, right? But yeah, let's not go that way. Right, so there's a free alternative to Illustrator, which is called Inkscape, so that's something you might want to look at. For layouts, books, we still have got one competitor left, Quark Express, yee, still surviving. And we can do LaTeX. Did you ever do LaTeX? No? As a computer scientist? Never? Do you know it? Okay. So there are other ways of doing it.
So what's the benefit of
LaTeX
over something like Quark?
I might actually dedicate a whole lecture to LaTeX.
Yeah, I'd be interested in it.
Yeah, so LaTeX is what would be the appropriate. It's a text-based language, not similar, but when you know HTML is a text-based language, right? And you separate content from style. So in the same way that in HTML you would have a CSS file defining the style, and you don't worry about it when you write your text, so is LaTeX. So you just write, and you later on attach a style sheet, you press compile, and it spits out the perfectly designed PDF. So it's a thing of beauty. For screen design, well, that's on the move now. So it used to be Flash, but it has fallen into disgrace. So now we've got HTML5, and there are several different tools these days. Dreamweaver is the old working horse, but there are also more advanced ones now that are more targeting towards animation.
Successor right now. animated or something. Okay.
Oh yeah, right. They don't call it even Flash anymore. They call it the software. The Flash Pro is now called Animate. Yeah, and it spits out HTML5. Yeah, so times change. Yeah. So there are a lot of. I wouldn't even be able to list or give you good recommendation these days about which HTML editor to use. It's like it's become so wild. But I guess there's a difference between those that are emphasizing, let's say, you see what you get versus code, right? And, or a mixture of the two. But I guess you are no better than me these days. All right, all good so far? Right, then your task for next week, Monday, would be a logo. Please design me a logo. And I would like you to pick a design classic, and I would like you to describe its history. And I want you to create a logo for this product. Because the logo has to be about something, right? You can't just make a logo, right? It has to be about something. So it should be about a design classic. Do you have any idea what a design classic is?
Like a Model T Ford, something like that.
There are some product designs that are just classic. For example, the old classic Beetle, the car. Now that's a classic, right? So there are certain products that withstand the test of time. So they look as good now as they did 70, 100 years ago.
E-Type Jack.
So you got some ideas, right? If you want to, pick something that is close to your heart, right? If you're a big fan of cars, maybe you do the Beetle. If you're a big fan. So, do you remember what the logo was for the new Beetle? No, you don't remember? When they first came out with it, I think around 2000 or so, they did a relaunch of the old Beetle. And the logo was this. Right? Now, so print a picture of the product, its history, and your design explanation on one A4 cardboard, and the logo itself on another. The PDFs you upload to Learn. The prints you bring to class.
Individually or as a group?
Individually.
A4 cardboard?
Mm-hmm.
It's different from paper.
Yes. We actually went through this slide today.
Yeah.
Yeah.
Where do I get it? Where do I get it?
These are all very interesting problems.
With that, are you wanting it printed directly onto A4 cardboard, or are you meaning it backed onto A4 cardboard as well?
As you desire.
And with a design classic, are you after one that essentially part of the brand is part of the product, or could it, for instance, be like a Still 12 espresso machine, and that's a product that you're then designing a fictional brand for, like a logo? Or are you really meaning like a quintessential branded one?
It should be a logo for the product itself and not for the company that produces it. So we don't want to have the Volkswagen logo, we want to have the Beetle logo. If that answers your question.
Yeah, I'm just meaning as to the design history element of it, like.
Well, the point is, see, you have to understand, your design choices, and supposedly you select a product that none of us knows. It is good for us to understand, what is this product about, to be able to judge whether your design is any good.
Yes, so I just mean as a focus more on like part of the company history that led to, and the factors that lead to the product being created. So I'll talk to you.
Okay. Okay. Now, I brought two books with me today. This is my absolute favorite, but unfortunately it's in German. These guys, they're just insane. They just tell you everything precisely. They tell you everything, like how you're supposed to do this, how you're supposed to do that. I mean, it couldn't be any more how you format phone numbers. You know, it's just anything you can think about. They kind of like tell you what to do, which is kind of nice. But unfortunately, only the Germans are crazy enough to try to do this. The best English one I've found so far is this one, which is very practical instructions on how to get stuff done. So I kind of like this quite a bit as introduction to typography and lots of other things. So it explains a lot. So I'm still always on the search for good books. You know, maybe if you find another good one, let me know. But this is a nice one as well. These are, as I found, there are typically two types of books in the area of design. They are like the to-do books, which are these, which tell you exactly this is how it's done. And then there are the kind of like inspiration books, which are like the 100 best, you know, corporate identity designs. And then it's a collection of ideas, a collection of examples, which are good for inspiration. You know, I usually go through them and steal my ideas from there. But if you want to do it yourself, or you don't want to do it yourself, then the how-tos are a bit better. All right. Any other questions?
Can we get the Adobe Suite on our computers out there?
Adobe. Yeah, so Adobe is difficult. So the university, as far as I know, does not have a site license for Adobe products, which is a bummer. Which means the best bet that you have is to install Adobe CC on your computers and purchase a student license. Now, you will be needing this for approximately at least 14 weeks, maybe a bit more, so like 2-3 months. They charge not that much per month. They actually have a subscription model these days. You pay per month. So that's probably your cheapest way of getting away with it. The lab does not have the ability to handle this. So we do not have licenses. We do not own licenses for students here. We do not have a computer lab where there are pre-installed licenses. But I would highly recommend that you familiarize yourself with Adobe. Very simple, because it is the industry standard. And for your own set of skills, that's probably what you will need. So you're probably well invested if you pay for those 2-3 months for the subscription.
Is the license valid on multiple machines or only one?
That's a very good question.
Yeah, I've in the past when I've had a CC subscription, it's been okay on both my laptop and my desktop computer, so I think at least 2 is okay. But I would double check that with the student one, because that was like a professional.
I think to use it, you have to be logged in, and then if you log in with your Adobe ID, I think maybe they're limited by you can only log in with one Adobe ID or something like that. I'm not sure. It's a bit confusing. I struggle with it myself.
Yeah, the student one at the moment is about $20
$20 per month?
Yeah.
For the whole thing?
Yeah.
That's sweet.
Yeah, it's not too bad. 3 years.
Last time I looked at it, it was the full license, and it was just like, here's $500 just for Photoshop.
Yeah. Fortunately, the education and student ones can be a lot more reasonable.
Yeah. Okay. Other questions? Then, yeah, next week, Monday, so the deadline will be for this, in Learn there'll be an assignment where you have to upload the PDF file. This will have a deadline, which will be essentially Monday at 10 a.m., I think, normally. So my recommendation is do not attempt to print on Monday morning. Printing always fails. So don't do it an hour before. You will be doomed.
Where do we print? Do we print it here? Or?
That's a very good question. Do you have a printer at home?
And I know there's the print center down at Undercroft.
Mm-hmm.
A lot of printers here take cardboard.
And how do you get cardboard through a printer without breaking it?
Yeah. Well, some printers will take it, like reader paper.
Please don't break our printers.
Oh, no, that's why I'm asking. Is ours that kind of a printer? Yeah.
So you see there are some challenges, and also I'm not going to tell you the answer right now because I want you to experience the difficulties. That's why I don't tell you. These are all problems that you'll have to find a solution to. Okay? All right, then good luck with that.